Welcome to the Cannabis Analysis, the podcast that covers all things cannabis. We're going to talk, debate, examine, and get great. We are now live on YouTube, Rumble, and Kick. Don't forget to join our locals community. The link tree will be in the description box. All right, so how are we doing out there, fellow Cannabisians? Welcome to the third episode of the Cannabis Analysis. Today we're going to be talking all about Phenohunting. Now, Phenohunting, I guess the best way I can explain it is having multiple seeds of the same cultivar. So if I had Purple Haze and I had 50 seeds, I would pop all 50 seeds, sprout all 50 seeds, let them grow out, cut clones to preserve each of the genetics, flower the plants out, and see which phenotype or taste, effect, any quality that I enjoy through hunting through these. You're trying to find the best expression of the strain cultivar that you're looking for. This is quite a process. This can take years, but the main reason of pheno hunting is to either back cross, S1, or breed with another plant to make another F1 or true breeding stock by mixing a male plant or two female plants of different genetics together, either through natural pollination, colloidal silver, or what is that? Silver thiosulfate is the most popular mixtures that people use. But this is just to preserve genetics, to keep qualities and traits that you like. Not necessarily all plants from the same genetic strain. Say that not all Purple Hazes will be the same, so the hunt is to find the best representation of it. Now, I have a few articles here that we're going to read from that can also help us to explain what's going on with the pheno hunting and hopefully give us some tips. I also have a video as well to help further break down the reasons for a pheno hunt, the results of pheno hunting, and why you would even want to do it in the first place. So, as I spark up my J, we're going to get into the first topic of today. So, bam. And this article is from Seeds Here Now. The ultimate guide to spectacular pheno hunting and cloning. 10 quick tips. Now, I figured this would be a little quick introduction. I hope I picked the right article. I have two to go through. But the one-on-one made me feel like, okay, this is going to give, from beginner to advanced, a great overview of what pheno hunting is. So, cannabis cultivation is an intricate and delicate art, demanding patience, knowledge, and a key eye for detail. The all-inclusive guide will explore the fascinating world of pheno hunting and cloning, providing invaluable insights and practical advice to help you become a master cannabis grower. We also address the unique nature of cannabis phenotypes and why they are critical in the cultivation process. All right, so number one, understanding cannabis phenotypes. So first, what is a phenotype? A phenotype refers to a plant's observable traits or characteristics resulting from the interaction of its genotype, basically the genetics that it has, and it's mixed with the environment. In cannabis cultivations, phenotypes represent distinct variation in plant appearance, growth patterns, flavors, aroma, and potency. So, that basically means that, we'll go back to Purple Haze again, I'm gonna wear it out today, that Purple Haze grown in, say, Idaho of the United States is not going to come out the same as Purple Haze is grown in the Kush Mountains. of wherever, Pakistan, wherever you want to go, Afghanistan, they're going to come out totally different and have totally different representations, different colors, and that's due to their environment. I guess even with the makeup of people, depending on the region that we come from, give us different genetic traits. So this is something very similar. We're all humans, but our environment makes us express outside visible characteristics and traits that you can see from us dealing with that environment. Okay, now why are phenotypes important? Phenotypes play a vital role in determining the overall quality, yield, and unique characteristics of cannabis plants. Understanding and selecting the best phenotypes can help growers optimize their cultivation process, resulting in a better final product. So, that is to say, I'm just going to go anecdotal from back in the 90s when we would get a pack of seeds. Say we get a 10-pack of seeds. And back then they were just regular seeds, so they were not feminized necessarily. So out of 10 seeds, let's just say on rule of average, you get 5 of them that are going to be males. So that means you're dealing with 5 females, and out of those 5, 1 is going to be better than the other. Hence we get to gelato 43s, gelato 33s. We get to NL5s. These are different phenotypes within a pheno hunt, judging from like flavor, structure, the different things that they're describing here. And the unpredictability of cannabis seeds. Unlike seeds of other plants such as corn or green peppers, cannabis seeds can produce plants with significant variations in phenotype, even when originating from the same parents. This genetic diversity makes phenohunting essential in cannabis cultivation. So that was addressing what I was just talking about right there, that no two plants will necessarily be the same, and there will be better representations of a certain strain or cultivar depending on you, the grower. That's where the art comes in. What do you like? Some people go for color. Some people go for potency. Some people are going for effect. Some people are going for ease of trimming. All of these are different factors, but it's all on you. That's what makes it the art. So let's go into the nitty gritty, the good part. How to pheno hunt, the fundamentals. So of course, in order to pop some seeds, you're gonna need some seeds to pop. So seed selection. The first step to any pheno hunt is choosing the right seeds. Opt for seeds from reputable breeders and stable strains to ensure a smoother pheno hunting experience. Okay, this is a shameless plug for seeds here now in that one. Environment and growing conditions. Consistent environmental conditions are essential for accurately comparing different phenotypes. Maintaining a controlled environment with stable temperatures, humidity, and light. Now, this is very true. Now, they had mentioned the genetic diversity, and that's what I was talking about when saying the purple haze grown in Idaho is going to be different than the purple haze grown in Pakistan or Afghanistan. That's the genetic diversity. Within all of the plants, there's certain traits that they can pull from. And depending on which plant, they're going to pull the different traits. Hopefully you get the correct combination. From the way I heard someone put it, you're kind of going for a deck of cards. And however you shuffle the cards, bang, now it's the deck. You're hoping with each pheno hunt to get kind of the exact same shuffle that you got before, if not better. It's a lot of different factors in it. I think you're mostly, when you're pheno hunting, you're going to try and pull out recessive traits that aren't necessarily dominant, such as a green color and orange pistil hairs. You're going to be looking for recessives such as pink hairs or red hairs or a purple color instead of a green color on the leaves. The recessives are kind of what makes the thing stand out, and I think the same thing for people. The green eyes, the gray eyes, those are the rarities, and you can definitely see the value in that. You're kind of trying to, I guess, go for that when you're the hazels. You're trying to pull these recessive traits out in the pheno hunt to get the best expression. That's really going to be the only way you're going to get something different, if not necessarily the best expression. Because different is also good. Let me not underemphasize that. I mean, you got people who like what I guess skunky, dirty diaper, then the more floral people, the I guess more citric, the like Calios. But your end result is really definitely going to start out with what they said: seed selection and keeping that stable environment. If you can grow, we'll go back to the 10 pack of seeds and the 5 females. If these 5 females are basically kept in the same temperature, humidity, light, they should all not have as much deviation, and it makes it more scientific of a process, so you can see the little nuances between the 5 different plants, because that's what it's going to be, little slight details. This high lasted an hour longer than that high. I tasted more lemon than orange peel in this one. This one had more frosting. I noticed this had a little more color variation, these different expressions that come out. Because the main thing with the Phenohunting is the plants have, I guess with all living beings, you have the ability to go back into the past and pull genetics from 3, 4, 5, 6 generations away. So every seed that you pop has some kind of value, if nothing else, to see what it has. You never know what's going to be exceptional, and you never know what's going to be a dud. So identifying, this is part 3, identifying exceptional phenotypes. Key traits to look out for. When pheno hunting, search for plants traits such as growth patterns, yield, potency, and resistance to pests and diseases. Also pay close attention to the more subtle characteristics like aroma and flavor profiles. And that's very true. It's going to be very, very subtle like that. Structure, like they said, growth patterns. Now the leaf to calyx ratio when you're going to flowers, the actual frame and structure of the plant growth. Is it short and squat and wide? Is it skinny, lanky, and tall? All of these different little nuances are going to have to be noticed. And the main thing, this is a lot of note taking. You, I guess in essence, could really pheno hunt with as little as 3 plants, but most people go up to 1,000 plants during a typical pheno hunt. At least 100, because you're going to have to see in any kind of breeding, there's going to be 50% of it that is going to display traits of the male, both parents. You're going to have 25% of it that represents the one of the parents, and you're going to have 25% that represents the second parent. So out of what, the 100 or 10 or whatever, you're at least going to on average have those numbers to deal with, and going to have to pull out the exceptions from, I would definitely say, the 50% batch is what you're looking for, the marriage of the both parents, because that's the main reason you bred them together in the first place. So the magic of aroma and flavor. In the world of cannabis, flavor and aroma are crucial factors and heavily influence the overall quality of the final product. Take note on the sensory aspect of pheno hunting to ensure that you getting the most desirable phenotypes. And yeah, I would definitely say you're going to have a great palate for this, a great nose, and a great, just great taste buds, basically, because that's where your smell comes from too, air going over your taste buds. To get like root beer or apricot, these hibiscus, these very, very subtle coriander, the currant, like very, very subtle flavors that you're getting. The sweetness that you may get, which there isn't actual sweetness, but certain things make humans perceive that there is sweetness. But very subtle, different nuances, down to the picogram of flavor. Like I was saying, that out of the 4 major citruses: lime, lemon, grapefruit, and I forgot the other one. That I guess pink grapefruit was what I was thinking about, where I got that one from. Even though they all contain citric acid, there's all subtle nuances between the difference of all of those. And it can be as subtle as that when growing plants in a pheno hunt, or it could be very, very overt and you notice it right away. Hey, this plant is like a foot shorter than this plant. I can clearly see this as a different phenotypical expression compared to this one, even though all the plants in this pheno hunt are from the same parents. My coffee's still hot. All right. It's a good day so far. Good day. And I hope y'all are feeling pretty good out there. I'm back to smoking the original haze today. And it's been about 3 months. Yeah, about 3 months of cure now, and I really noticed the difference in not only the earthiness of it, but the citrus of it. That haze taste was always in here, but that it's actual orange meat, not the zest, like the peel of it, that this tastes like, actually like biting into an orange. Is very fresh, and the earthiness, like the dirt, is like a fresh rain type of taste and smell. Fresh rain on soil. That real earthy, like potting soil mix smell. Well, there's more of the taste, but it really came out in this. So we're going into number 4, the Phenohunting process from seed to harvest. That's me. I'm not purring. I was doing a drum roll. The Phenohunting process. Germination and seedling stage. Excuse me. me. Germination and seedling stage. Begin your pheno hunt by germinating your seeds and closely monitor their growth during the seedling stage. Look for strong and vigorous seedlings to move on to the next stage. I almost forgot about this part. Now, the bad part about pheno hunting is because you are popping so many seeds in a pheno hunt, you throw plants away. So if it doesn't make the cut, if it's not vigorous growth, there's no point in wanting to continue that, I guess, that line or that phenotype, unless I guess the plants are going to eventually end up giant and you find one that's like a dwarf and you are looking for that, possibly. But yeah, nobody wants to continue the bloodline of midgets, I don't think. We want some Andre the Giants. Okay, so the vegetative stage. As the plants enter the vegetative stage, continue to observe their growth patterns, branching structure, and overall health. Eliminate any weak and undesirable plants at this point. Okay, so this is the second phase of getting rid of things. I think getting rid of them at the seedling stage is very vital too. Things that take a long time to pop or very staggered growth. And yet again, this is where the note taking comes in. Like realistically, depending on the seed, sometimes plants get names in the seed. If the seed is big or small, I'll call it like Juggernaut or Pee-wee or something like that. But number or name every one of the plants so you kind of know what you're dealing with. Like I was saying before, with the Gelato 41 or Gelato 33 NL5, just to kind of have an idea name association with what your plant's going to look like and what you should expect out of the growth. What is the true phenotypical expression you're looking for? Like I said, out of the 50% marriage between the two parents, the 25% of one parent representation and 25% of the other parent representation. Out of those three scenarios, what are you looking for? And then what is the best expression out of those three scenarios, whichever one you come up with. The flowering stage. The flowering stage is crucial for determining the final product. Assess the plant's bud structure, trichome production, and aroma. This stage is also the best time to determine the plant sex and remove any males if needed. Okay, so this is, if I guess I was natural breeding, true breeding, or whatever with male and females, I have either gotten plants that have seeds that have reversed themselves naturally, or using a STS spray, a silver thiosulfate, which basically blocks the, what does it block? The male crap in it? No, it blocks the estrogen in the plant, and it makes the plant pretty much pollinate itself. So a S1 is what you end up getting. Self by itself, first generation. Harvest and curing. After harvesting and curing your plants, evaluate the final yield, potency, and overall quality. Choose the plants with the most desirable traits and keep them as your keepers for future cultivation. So see, every time I've gotten to this part, I was worried about this from reading the article. It took me years to figure out in a pheno hunt, before I did a pheno hunt. And it wasn't until I actually did one that I was like, yo, how do you keep a plant going around? They never mention how. And I'm noticing that in this, that they never said take clones. Like during the vegetative stage, before you flower it is when you want to take your clones. And the main reason you would limit your numbers is just from space. I understand these things, can pretty much be stored in the size of a quarter when they're seeds, but they're going to need a 5 to 15 gallon bucket when they're full grown, depending on your veg time and flowering time and the cultivar stretch and everything. So the sooner the better that you can get these clones out to, I guess, assess what space it is and to eliminate as many plants that don't make the cut as soon as possible for the space. That's the main reason I would want to be getting rid of plants, is just so I can have a longer veg time, because I don't need as much space. I wouldn't need as much space to store all the stuff in veg if there's not as many plants, and therefore I can have a longer veg time and thus a bigger plant flowering and finish flowering and all that good stuff. So that would be the main reason. I'd want to take clones right away, kind of get this done right away with anywhere from, I'd say, really like if you're pheno hunting, you really want to see what these plants can do, I would go a 6 to 8 week veg time. And that, like the 8 weeks, the plant is going to be humongous by that point. It's going to be like 4 feet tall, and that's why I'm stressing hey, hurry up and get this in the flower and get some clones. Be dealing with like a 6 to 9 foot plant by the time it's all said and done. And that's just one plant. So depending on the size of your tent, like I'd say like a 2x4, I'd say at the most you can go 3 plants, because you're going to want to give it a long enough veg time so you can see the structure, which is going to create bigger plants, thus having less space in the tent. So the size of your pheno hunt really does depend on how much space you have, but also the things that you do during this time. So we'll go over the germination and seedling stage. You'll kind of notice when it starts to enter actual vegetative growth. Once you're satisfied where the plant's at, I would, a week before, I would take the clones, give it a week more veg to kind of heal from the cutting of the clones, put it in the flower, and by that point, the clones should be somewhat rooted and ready to go back into the veg side. Then when you try all of the finished flower, that's how you actually determine which plants out of the clones that you kept you actually want to keep. So you could end up, let's say you do a 20 seed pheno hunt. You could end up with 20 clones originally, but once you try the strands, you only like 5. So boom, you can get rid of 15 of them. So it's hell some at certain times, but it's also once you do so many and you eliminate so many, you're like, dang, I don't really have anything else to do. I guess like Squid Game, you start out with all these personalities, and by the last episode, ain't nothing. So the art of cloning and cultivation. Why clone? Cloning is a technique used to create genetically identical copies of a cannabis plant by taking cuttings from a mother plant and nurturing them to develop roots and grow them into new plants identical to the mother plant. Cloning is advantageous as it allows growers to replicate the desired traits of a particular plant without the need of seeds, ensuring a consistent final product. And yet, every time you pop a seed, you're back in that pheno hunting game trying to find the best representation. So why you take the clones is to know that you have the exact plant that you wanted. You don't have to do, there's not a second hunt on top of the hunt. So number 6, cloning and pheno hunting, the perfect duo. I mean, it seems necessary, and bro, perfect duo. It's like chocolate and peanut butter. You gotta do it. Chocolate milk. Preserving the best phenotypes. Combined cloning with pheno hunting allows you to preserve and propagate the most exceptional phenotypes, leading to a consistent high-quality cannabis strain tailored to your preferences. This synergy between pheno hunting and cloning helps refine your cannabis strains and optimize your cultivation process. Well, really, without the cloning, it's like the chicken or the egg or whatever. What came first? I think without the cloning, there's really no point in pheno hunting, because if you find the best strand ever in the world, but you couldn't clone it, what's the point? So I think they kind of both go hand in hand. There is no pheno hunt without cloning. Number 7, selecting the ideal substrate for clones. Okay, rockwool. Rockwool is a popular choice for clones due to the exceptional water retention and air permeability properties. It provides a stable and sterile environment for root development. Yeah, very convenient. Any of those little block cubes you see, I do like them for clones as well. Clones and popping seeds, I really enjoy rockwool. Cocoa coir. Cocoa coir is an eco-friendly renewable substrate that offers outstanding water retention and aeration. It is a natural biodegradable option that promotes strong root growth in clones. Yes, it is inert, meaning it has no life. It's like plastic basically, but be careful where you source your cocoa from, because from what I understand, how did someone put it? A lot of these the coconut places are by the water, and they have a lot of a high salinity rate if they don't basically prep everything. If they just take it right from the field and ship it, it might have a high salinity. So you might want to be careful where you source your cocoa from. Peat pellets. Peat pellets are compressed peat moss that expand when soaked in water. They provide a soft, moist, and well-aerated environment for root development. I used to really love peat pods. I guess like 92, 93 is when I first got exposed to them. And I love them things. They were great. I guess that was the predecessor to cocoa coir. Aquaponic cloners. Aquaponic cloning systems use a nutrient-rich mist to provide an oxygen-rich environment for root development. They can lead to faster rooting and higher success rates. That is true. Just the molecular size of the water allows for better absorption. Like I heard like an hour and a half seminar on aeroponics back when that technology was new. And it was the rage for quite some time, but I guess the same thing with hydroponics. I don't hear too many people talking about it now. So pheno hunting with clones, is it possible? Well, yeah. Ain't that what you doing? Okay. I'm confused. Phenohunting with clones is indeed possible and can be highly beneficial when working with new strands or refining existing ones. Starting with a diverse set of clones, phenohunting can help identify and propagate the best performers, ensuring a consistent and highly quality final product. And where to acquire quality clones? Okay, from local dispensaries, cannabis cultivation clubs, online forums and community, friends and fellow growers. Oh yeah, okay, they have a little disclaimer here. I guess I should read it. Always verify the legality of acquiring and growing cannabis clones in your area before proceeding. And to bring it on home, the conclusion, number 10, mastering cannabis through phenohunting and cloning. Okay. By understanding and embracing the world of phenohunting and cloning, you can elevate your cannabis cultivation skills and consistently produce top quality strains tailored to your preferences. Follow the tips and best practices outlined in this comprehensive guide, and you'll be well equipped to embark on a phenohunting and cloning journey. Keep learning, stay curious, and watch your cannabis garden thrive. Well, it would have been nice to say how you clone, basically, and you're taking a branch from a shoot that is going to be a flowering shoot from a cannabis plant. You would like to cut it at a 45-degree angle at the tip of it, and the main reason they recommend the 45-degree angle is if you cut it flat, it's a lot easier for that opening to close up, and you get a lot more time for roots to establish, the hormone to build up in a plant. If it's cut at an angle, it can't heal that wound as easily. So extra credit, seeds here now, bonus content, concerns when acquiring clones. Oh, HLVD, yeah, the hop-laden viroid disease. Yeah, just be careful. That's all they basically saying. Thank you, seeds here now. Now we're gonna go on to phenohunting, phenotypes of phenohunting. Let's just make sure everything looking good, everything's looking great. I guess that's a nice little vape cartridge dude has there in his hand. So let me see if we need to go into this prerequisite real quick. I'm gonna just skim through this. Okay, no, this is pretty much the same opener as before. You know, hey, phenohunting is important because you're looking for color, smell, and you want the best representation of so on and so forth. So now, they're okay. Oh yeah. Now this was, I know, I probably should have read this. Well, no, if I read this article first, the other one would have been dumb. One of the most important parts of phenohunting is marking down the different phenos you have researching. More often than not, they can be marked by numbers or letters, i.e. chocolate kush number 3. The 3 symbolizes that's the third one in the group of phenos hunted that made the cut. That doesn't mean kush number 2 was bad, but rather that number 3 was simply a better representation of the parents of the charcoal kush. But it gets even more complex from here. Sometimes breeders will like a pheno so much that they will turn around and want to breed with it themselves. This is where you see breeders use vocabulary like BX1 or F2 or S1. But what do they mean? Let's break it on down. So this is good. I figured this was something I had mentioned in the first article. So I knew it was going to come up, and I wanted to make sure that these expressions were, these terms were explained and everybody could get some easy definitions. I'm sorry, my words getting swugged. I'm slurring my words a little bit. Sorry, I'm feeling the effect of the haze. Do you feel the effect of the haze? There we go. Now, we're going to go into terms like F1. Sorry about that. Just a little parched. F1 stands for first generation hybrid. This means it's the first generation offspring from your initial plant. In other words, this strain has been picked, the pheno has been hunted and selected, and F1 is the first of that new batch. F2 would then stand for a second generation hybrid, which would essentially be an F1 batch bred with another F1 batch, producing even stronger genetics and characteristics for that newly bred strain. F2 strains are bred to create F3 and so on and so forth. Now, are they going to, okay, let me see if I can remember this. F1, like I said, that's the 50% both parents, 25% one parent, 25% second parent. F2 is where you get just everything from the genetics of both parents. So you can go back 5 generations from parent 1, you can go back 5 generations in parent 2, and they all come together in the F2. So you could, just to try and explain the extremities, you could go from peppermint to coffee to grapes to skunk, all in the same seed pop of the F2s, because you're pulling so far from both parents. That's where things get funky. Like, you can get anything out of F2, and that's really where the true phenohunting is. And that when you get to the F3, that's where recessives start getting pulled out. So if there's any hermaphrodism in there, that's when that's going to start coming out of the plants. When you pop 10 seeds, 6 or 7 of them might herm, depending on where you steered your pheno hunt and your breeding project. You have the dwarfism, the weird mutation of the leaves. That's going to come out in the F3. And by the time you get to F5, which I know that DJ Short's Blueberry was down to F5, you get stability, you get uniformity, homogenization. Like, every seed is going to turn out the exact same. But by that point, a lot of the plant vigor is gone, meaning it's struggling to stay alive and grow. Instead of, I guess, starting from a seed from an F1 with that initial vigor, it's like a baby growing. By the time you get to the F5 generation, it's like an old man growing. It's there, it's alive, but it's not thriving. So usually when about the F4 is when I like to go into it. When I get to the F4, or I make it past the F3, or I find a good F3, I'll go back with the original parents just to strengthen up those genetics. And that would be a back cross. No, shoot, they about to say it. But yeah, that would be back crossing it, like re-strengthening genetics that I want. I got the genetics from the parent. It expressed itself in a good way now. Bring it back to the parent to kind of reinforce that trait that both of them share. And hopefully with the new BX1, what the C would be called, not an F1, but a BX1, because I back crossed it. Hopefully that locks in the trait that I'm desiring. Still gonna be another pheno hunt. Now, S1 stands for selfing. Selfing is a chemically induced process. Can be done naturally, but it's just usually due to stress on a plant, due to light leaks, having a bunch of females in a room with no male at all through the whole point of the life that will happen. Yeah, just any kind of stress will really, temperature can do it. But they're saying chemically, as I was saying, colloidal silver and silver thiosulfate are the 2 most popular things to reverse plant genetics from female to creating its own pollen sacs and pollinating itself, creating the S1. Okay, so Oh, okay. It's a chemically induced process in which a breeder will stress out a female plant. The female plant will then produce male flowers. These male flowers will then pollinate the female plant, which in effect is a plant essentially pollinating itself to produce even stronger genetics. Yes, but kind of the thing with S1s is it kind of puts you in an F2 situation where you got so far from genetic pools to pull from. You can get peppermint, licorice, chocolate, uh, cotton candy, charcoal, steaks. So, there's no telling what you're going to get from a F2 or an S1. That's like a box of chocolates. So IBL stands for inbred line seeds. The IBL seeds are distinct from F1 seeds. IBL seeds become available after the 5th generation of F1 seeds. So if you decide you want to purchase quality genetics, you would want to ideally be looking for IBL seed. Basically F1 with F1 with F1, like breeding, going out to F1, pollinate with the F1, going out to F1, pollinate with F1, generation after generation after generation will get you the inbred line or heirloom. I guess that's another way to put it. So BX, we had talked about this earlier. BX stands for back crossing or back cross. Back crossing seeds is when you take an F1 and breed it with the original parent plant. This result is a BX1 seed. You can find BX2, BX3, which means that the new generation of back cross seeds are then once again bred back with the original parent plants. This is to preserve a particular characteristic of the original parent plant. So that is true. The main reason you would want to F1, F2, is kind of like forward. You want to progress the line. You BX or back cross because you want to lock in a particular trait. Like effing going forward locks can bring out multiple traits. Back crossing locks in one or two particular traits. Finally, fast seeds are when a breeder has finalized the genetics. They have finished the back crossing and hybridized, and they have settled on their prize genetics. They will in turn breed that plant with ruderalis, a very sturdy non-psychoactive branch of cannabis, which helps plant autoflower or faster flower. Fast seeds are great for beginners. Okay. So I keep hearing fast something, and I wonder what that means, or if that's even a true term. But okay, it seems like an auto flower that's not a true auto flower. They didn't breed it all the way to perfection. From what I understand with auto flowers, it probably takes about, 9 generations of breeding to get it to do something. So this might be, say, generation 2 or 3, where you get the fast seeds that they're referring to. Interesting. Okay, I learned a little something out of that. And okay, now they have a picture here, and you can see this is probably actually from the same genetic stock, but they both are phenotypically expressing different. One is, I'm gonna just go ahead and say like a purple, and the other one is like a brown greenish. When growing cannabis strains, there are two main factors to consider: environment, which is your lighting, your tint, your pH levels, and nutrients. Another factor is genetics. Having quality genetics is quite literally half of the battle. Quality genetics can be extremely expensive. Oh boy, this is another shameless plug. With some exclusive phenos going for thousands of dollars and maybe a clone or two for a pack of seeds. Rightfully so, breeders can spend years and years looking for the perfect pheno. Furthermore, understanding phenohunting really opens the door for breeders' understanding of, oh boy, cannabis. will further help you explain to consumers why Blue Dream that they tried in Colorado is so much different than the Blue Dream they tried in Massachusetts. Okay, see, we addressed that earlier as well. So, okay, just a little, I'll go ahead and give Campfire Cannabis a little plug. They said next week we will talk cannabinoids, terpene, full spectrum, and the entourage effect. So, yeah, all about terpene. That's nice. Okay, okay, okay. Okay. And that wasn't bad. Now we're going to go into our next segment, the video portion. Now, I think I've already queued this up to the part
Thanks
where
for joining
the
us today
gentlemen
for
are
our
going
presentation
to
on phenotypic
introduce
expression and
themselves.
why
Oh,
it
this
matters.
seems to have started
It's
itself
easy
over.
to
Here we
realize
go.
that it influences every
So the
aspect
gentlemen
of
who are
cannabis
speaking
production.
are
That's
Jesse,
the reason we get
what's
so
that?
drawn to
Jesse
discussions
Porter
on phenotype.
and
In
Anders
this webinar,
Peterson.
we'd like to focus on the
Now,
meaning of a phenotype,
what Jesse
and why
Porter?
it is the foundation to
Yeah, I'm
success
sorry,
in
I
indoor
was looking at a
cultivation
small screen.
businesses.
He
With that,
was
I'd like
very
to turn it over
brilliant.
to
This
Anders
is
and let us get
an
started.
overall
Thanks,
great
Jesse.
talk,
I'm excited to be here today.
great
to talk about a
concept, and a
subject that
great
is near and dear to my
explanation
heart.
of
Phenotypes and
why
phenotypic
you would even
expression.
pheno hunt,
And really what we are talking about is the
what that means
uniqueness
to
of
a
cannabis,
company's bottom line.
varieties,
He's
and
coming
how
from
we
the
can
aspect
maximize
of
the expression of each cultivar.
industry.
There are more desirable
being a professional
phenotypes,
cannabis
and there are
grower.
less desirable phenotypes. Then there are certain varieties
But
stacked with so many
as a home
desirable
grower,
traits
the main reason
that
you
it's
would
like you
care
just
about
stumbled
pheno
upon a
hunting
unicorn.
is
It's a
you
keeper.
might make the strain that makes
Hunting
the
through
name,
all
you
this
can make the
variety in
next run
cannabis to
for
find something
Sunset
truly
Sherbet
special
or
is a huge reason
Blue
why
Dream,
people
they
devote their
said.
life to this plant, including myself.
Excuse me.
The variety keeps
That
it fun
could
and
be you.
interesting. The smells,
Gelato.
colors, effects,
So
or how
there's
it grows.
always a reason.
You might have heard of Skunk 1, Chem
a
90,
reason or incentive
Northern
to pheno
Lights
hunt,
5,
commercially.
all the OG Kush and
But
Girl
for
Scout varieties.
yourself,
These names and numbers represent a
you
unique
are gonna
expression
like what
of the
you
cannabis genome. And we're going to explain
and
how
you
that
can
works
tweak it exactly
and why
to
the
your
environment in
perfect
which they are grown is so crucial.
Make your perfect cup
Legends,
of coffee.
brands, and fortunes
That
are
is the
built
reason
on good genetic
I
potential
try and pheno
with
hunt.
maximum phenotypic expression. Let's begin with
I
the definition.
actually wanted to make the perfect
Phenotype.
haze.
The set of observable
I had always wanted
characteristics
haze,
of an individual
I guess around
resulting from the interaction of its genotype with the environment.
Till about
And in regards to
2007,
cannabis,
something like that.
phenotype describes the
Purple haze
plant's
was out there,
physical
I guess.
appearance or
I
form,
want to have
its
this all the
developmental
time,
growth,
and I actually
its
would like to make it better.
biochemistry, and its behavior. The key words to focus on
So I
here
got my chance.
are interaction of
Finally got a place
genotype
to
with
grow.
the environment.
It was legal.
In fact, this definition is
Strawberry
often
haze
simplified
seeds
and represented
some
as an
OG
equation.
seeds, actually 3
Genotype plus
seeds,
environment equals
sprouted them.
phenotype.
2 grew.
So really, there are two factors
OG
that
Kush was the
generally
female, and the
influence the way a
strawberry
plant
haze
grows.
was the male.
The genetics and the
Got
environment.
seeds and bred with
The
each
environment
other.
is 50% of
And
the
then for the
equation.
next 2-3
And
years,
that is why having precision environmental
indoors
control in your
and
facility is so
outdoors,
important. The term phenotype can be used in
I
two
bred-
different ways. It can get kind of a little
I
bit
called it
convoluted.
dieselberry.
Phenotype can refer to a singular trait that the
We
plant
got a lot of
displays.
that first
For example,
taste, but
color.
it was a
This plant displays a purple flower
in
phenotype,
between a
and this other
raspberry
plant
and
displays a
blueberry
green flower
taste.
phenotype. Or it can refer
that
to
strain.
all
It
of the
was very
observable
interesting.
characteristics
A lot
displayed
of gas,
by a certain plant.
more so in the
The
aroma
phenotype
than
of
the
this
taste.
plant is more desirable than
It
the
was
phenotype
really more
displayed
so
by
the
this other
berry, but
plant.
on the back end you would get the
Scientists
gas.
tried to clear this dual meaning up by introducing
So
the term
after I was
pheno
kind of satisfied with
similar
that, and
to
I guess
genome,
also more so
to
bored,
describe the collection of traits a plant exhibits. But this was
I got
never
my
really
hands on.
universally adopted. So we use
Super
phenotype to
wave.
describe a singular trait or an accumulation of all the traits expressed by a plant under certain environmental
same way.
conditions. Another
Read that
nuance to this definition of
2-3
phenotype
generations,
is the word
and ended
observable.
up calling that
But that doesn't mean
octane
just with the
haze.
naked eye. It can also mean
Read that
traits
for about
that
2-3
can be made
years, and
visible
going out to 2
by
or 3
some
cycles. I'm
technical
saying
procedure,
years.
like in a
It
laboratory.
was years, but also
An example of this
cycles.
in humans would be blood typing.
After
You
the
can't see
summer
it with the naked
season,
eye, but it is a phenotype of yourself.
outdoors
And in
was coming to a
cannabis, the
close.
cannabinoid and
I
terpene
would take the
profiles that we
clones
see
and
on
continue them
laboratories
indoors over the
to
winter.
describe the
Cut those
unique
clones and
chemical
bring
expression
them
of the plant.
outdoors
We use the
during
term
summer.
chemotype, or
So
sometimes
just
chemovar,
from a breeding
which is the
aspect
chemical
or
phenotype.
phenohunting aspect to
This is the
see what the
cannabinoid and
different
terpene
environments would
quantities and
do.
ratios that a specific
Then,
cannabis
just
phenotype
this year,
produces.
I took
Currently, there are about 5 broad classes of cannabis
what
chemotypes
strawberry haze and
based on
OG
the
Kush
dominant
to
cannabinoid
mixing
that
it
was
with purple
produced.
haze. So I mixed it with the original haze.
Now that we have
I
a
got from
base
Authentic
understanding of
Genetics,
what a
and
phenotype
hoping to make
is,
a heavenly haze.
let's dive into what a genotype is, a quick
Something
refresher
that's
on how
extremely
genes are
cerebral.
expressed, and some examples
And
of how the environment can
From the
affect the
effects I got of
expression
the
of these
octane
genes
haze,
in
which
cannabis.
is parent one,
What is a
and how I
genotype?
felt from.
A genotype is an organism's complete set of genetic.
I did not know this was going on. Yeah, I had no idea that was going on. I'm sorry. So as I was growing, I mean, I kind of did a little pheno hunt on my own. I'm sure I'm going to have to cut that out. So I'm doing this just in case. But I started out with strawberry haze and OG Kush. Had a couple seeds, actually 3 seeds, 3 bag seeds from those 2 cultivars. And it was legal. I had room. I grew them out. The OG Kush got pollinated by the strawberry haze. Boom, grew the females out 2-3 years. Then I ended up mixing the OG Kush and strawberry haze after I worked that. I called that dieselberry. It was very gassy and raspberry, like blueberry-ish kind of. It's definitely a berry taste, like a berry, like the skin of it tastes, and gas, like more so on the smell, but on the back end you can taste the gas. Bred that indoors and outdoors. Then I mixed that with purple haze. Took the purple haze and bred that indoors and outdoors. So what I would do is, towards the end of the summer for the outdoor stuff, I would take clones and continue that in the winter, over the winter, indoors in the grow tent, trying to see what the different phenotypical expression would be in both of those different environments. And also from a robust aspect. I know most people aren't going to necessarily grow outside. It's going to be more indoors. So I wanted them to be able to handle both environments is really the logic behind it. So this year, I took the octane haze, which was very cerebral, little bit of gas at the end, very orangey in the front, earthy in the middle. And I bred that with original haze from Authentic Genetics this year. And I'm hoping that it's going to be extremely cerebral and earthy. So I've been doing quite a bit of my own pheno hunting, and that's why I was saying earlier, hey, they didn't mention you got to take clones before you put these things in a flower, because once they flower, it's over. There's nothing you can really do. It's gone, baby. So we're going to go into the video now. And I think this was a really good talk. I really appreciated the 2 gentlemen here. Let me go back a little bit here. So he explains everything very well. This is what Jesse Porter and Anders Peterson. And this is a very brilliant talk about coming from the industry side, why you would even grow anything, want to pheno hunt, how to pheno hunt, why you would pheno hunt, and the end result of that on your bottom dollar. So we're going to go into this. And sorry about that. I hit the wrong button on here. There we go.
And we're going to explain how that works and why the environment in which they are grown is so crucial. Legends, brands, and fortunes are built on good genetic potential with maximum phenotypic expression. Let's begin with the definition. Phenotype: the set of observable characteristics of an individual resulting from the interaction of its genotype with the environment. And in regards to cannabis, phenotype describes the plant's physical appearance or form, its developmental growth, its biochemistry, and its behavior. The key words to focus on here are interaction of genotype with the environment. In fact, this definition is often simplified and represented as an equation.
Yes. Now that's what I was looking for earlier when we were reading the two articles, was this equation right here. This is basically Mendel's equation. And Mendel, Gregor Mendel, is basically the father of breeding. We use all of his terms. He's the one who coined the phrase F1, genotype, phenotype. He was a scientist and a bishop back in the 1830s, I want to say. And his work wasn't used after he did all these experiments and discovered everything. He did his initial experiments off of peas. He noticed F1 and F2 generations and could pretty much predict what color variations he was going to get due to his breeding methods. He did all this bomb work. Nobody cared. And then like 20 years later, 3 separate scientific groups pretty much did the same experiment. And after they had done it, they kind of went looking, hey, does anybody else know anything about this? And sure enough, Gregor Mendel. So that's when he got his accolades after he was out the game. I used to be a pimp. I ain't a pimp no more. But this equation comes from him. The genotype. So whatever is in the DNA of the particular cultivar, strain, plant, whatever. So Afghani genetic. This is what they're talking about. Plus the environment equals phenotype. So phenotypical expression, if you're going to get the purple, from it having cold nights and building the purple as a way to resist from the cold and to hold in heat. What's that? Aoxin? Is it a squat? That's another reason Afghanis are small and squat, because of the colder temperatures. It's trying to hold in the heat. You have long, lanky, spread out plant sativas. Yeah, they're trying not to mold and sweat and get that breeze through. So that would be the expression of the genes, trying to reach for light, different things like that. So this is a very important equation. And this is another reason I say you want to take notes. You want to take notes. You want to know everything, to make it true scientific experiment and have accurate data. The more notes and details you can give, the better off you're going to be. Trust me, I made beer, and that recipe matters. Everything you did to make that beer. What did you mash it at? What did you boil it at? How long did you boil it? When did you add the hops? What hops did you boil? When did you sprout the plant? Where did you sprout it? What was the temperature? What was the rainfall? All of these things matter. When did you water it? What did you feed it? When did you feed it?
Genotype plus environment equals phenotype. So really, there are 2 factors that generally influence the way a plant grows: the genetics and the environment. The environment is 50% of the equation. And that is why having precision environmental control in your facility is so important.
Now, I thought that was going to be a push for some product. But he is very true about this. I just wanted you to see this portion. I'm going to go a little further because he's going to start to go into some industrial equations. Talking about cost of light per gram. Okay, yeah, he's going into genotype, how we're going to get the expression. Yeah, I think this is going to matter. I think y'all care. I don't think I'm the best teacher, so let's hear what he got to say.
Understanding of what a phenotype is, let's dive into what a genotype is, a quick refresher on how genes are expressed, and some examples of how the environment can affect the expression of these genes in cannabis. What is a genotype? A genotype is an organism's complete set of genetic material, although it is often used to refer to a specific gene or a set of genes in a genome. Think of it as like the basic genetic boundaries which define a range of phenotypic possibilities.
Yes. Okay. So let's just go with I guess the three main races, what, Mongoloid, Angloid, and Negroid. I guess you can get blonde, dark-skinned people. I mean, I've heard of that, like Aboriginal Australians. But more than likely, we're not in that environment, so it doesn't get expressed in that way. But I guess, say, as white person getting a tan, that would be a phenotypical expression, the tan. And their genes, they're pretty much look a certain way, but when the environment interacts with them, that's what happens. That's how their phenotype gets expressed.
Just like humans, cannabis is diploid and has two homologous copies of each chromosome, one copy from the male parent plant and one from the female parent plant. Each chromosome in the pair contains the same genes in the same order and place along the length of the chromosome. These genes then get...
Okay, that was too scientific. And they get passed on and mixed. Yeah, we're going to kind of skip past that a little bit. I didn't know it was going to be that.
Forms a single-stranded RNA transcript, which is then translated into a functional protein. And in this kind of oversimplified example to the right, this protein might help produce a purple pigment.
That was oversimplified?
And then the end result of this gene expression is a purple flower. Punnett squares are used by biologists to determine the...
That's what it was, a Punnett square. I could not think of the name of that to save my life. But this is the 100% of genes, the 50% that is both parents expressed, the 25 is the one parent, and the 25 is parent number 2. Punnett square, that's it. And this is how you kind of figure out what expressions you're going to get and the probabilities of it throughout your pheno hunt.
Probability of an offspring having a particular genotype. It shows all the possible combinations of paternal and maternal alleles. We have the parental genotypes with each of their dominant or recessive alleles, one allele from each of their chromosomes. Then we have the offspring's predicted genotypes and phenotypes.
Okay, yeah, this is where it gets complicated, because where you get to dominant and recessive of both parents, yeah, the math gets very, very small. 13%, 17%. So we're going to move on a little bit more. I didn't want to make y'all go to school. Okay, still he's at it. It's more science. Yeah, he's talking about phenotypical, like all the possibilities could come out of all the genes is where he's at now, just to make it easy.
Of this. Anthocyanins, the pigments that are responsible for all the purples, pinks, and colors we see in cannabis flowers.
Anthocyanins.
You must have a cultivar with the genetic potential to produce these beautiful pigments.
Yes.
But if the plant is exposed to too high of a temperature at the end of its flowering cycle, then you will not get a full expression of these colors, and the proteins that produce them will degrade.
That is
How
true.
cold do we need to get the room, and for how long? Nobody really knows yet. And it can vary from cultivar to cultivar. But the colder we get the room, we know that the slower the metabolic plate of the ramp will be. Too cold for too long, we could sacrifice yield. Too warm, we could lose some color. Nobody really knows, and it can vary from cultivar to cultivar. But the colder we get the room, the slower the metabolic rate of the plant will be. Too cold for too long, we could sacrifice yield. Too warm, we could lose some color.
Okay, now that is very true. That actually happened to me this year with the dieselberry. It was so purple. Jesus Christ. Yeah, it was more purple than this picture. The leaves were purple too. And the hairs on it were like violet. It was so pretty. It was like a non-medicinal flower. On the hair, pistol hairs, you can see like the white at the top, like the milky trichome head, but in the middle of it, it was like this indigo purple, like black lighty color within it. It was so beautiful, but the plant was so small. It maybe got 2 feet, and it usually gets about 3 to 4 feet tall. Like 3.5 feet is about average what I got out of the 20 times I grew it. But that was the most purple I got. Oh my goodness. So he is so right. If it's too cold for too long to get you that purple, you're going to sacrifice yield. And that's exactly what happened to me.
Really, it's a delicate balance to bring out these colors in cannabis. Another example is the day to night temperature differential. With a warmer lights on temp and a cooler lights off temp, we have a positive diff. This promotes stem elongation or stretch. With a cooler lights on temp and a warmer lights off temp, we have a negative diff. This suppresses stem elongation. And for cultivars like GMO, garlic cookies, that stretch crazy the first 3 weeks of flower, we can use this environmental crop stirring technique to keep them at a manageable height.
Oh, that was a nice little tip. The original haze was the same way. It was like, I guess, like right here when it started to flower. And then it's like me standing on my shoulders after it finished.
Now, there are many more examples of environmental influences on phenotypic
I
expression,
could have used that.
but more research is needed to determine exactly which genes are influenced by the environment and those that are not.
Interesting. So he was setting all that up for kind of my favorite part.
Most fun things to do as a cannabis grower is popping seeds and hunting for a new pheno.
Here we
With
go.
inbred lines of corn or soy, you
I
pop
brought
a
it all
million
together,
seeds,
baby.
and all those plants will look and yield very similar. But due to the variability in the cannabis genome and the lack of professional breeding to stabilize genetics at this point in the industry, primarily due to prohibition, a pack of just 10 or 12 seeds with slightly different yet related genotypes will yield a huge variability between plants. Therefore, most growers utilize clones. But before you can use clones, you must find a phenotype with enough desirable traits to keep in your stable as a mother plant. So the process goes something like this. Let's say I get a pack of 10 regular seeds from the same cross. They all germinate.
I'm going to learn you something today. I think this was the best way to sum up everything I was trying to say. I'm a good gatherer of information. I don't know if I'm the best at explaining that information. But hopefully, after this, you'll understand everything about phenohunting.
And then I arbitrarily label them 1 through 10 to keep track. They continue to grow and eventually start showing their sex. Dang it, I got 4 males and I'm not looking to breed, so I cull 6 through 9. Shucks. Number 10 was hermaphroditic, which is a sign of unstable genetics. And I don't want pollen in my flowering room. Let's toss it. Looks like on this pheno hunt,
Is
I
that
have
what I
5
said?
females to hunt through. So they continue to flower and begin showing the full extent of their phenotypic expression. 3 through 5 start showing some purple.
This is kind of like exactly what I said. Out of the 10 pack of seeds, 5 of them was males. And out of these 5, okay, yeah, you're getting different traits. He's saying, yeah, 3 of them is purple. Yeah, this is the fun of the pheno hunt. Oh, this is the fun.
And 2 stay more green. Phenos 1 and 2 have a cakey terp profile, and 3 through 5 smell like I just opened my gas tank. But wait, Pheno 3 is gassy and cakey. I like that. And maybe Phenos 1, 3, and 5 had a pretty good yield at the end of the day. But Pheno 3 had everything I was looking for.
Okay.
She is the keeper of the bunch. And I decided to call her Gas Cake number 3. And that's a simple explanation of how growers.
Gas cake number 3. That was easy. How did you not see that coming? But he's right. This was a very good, simple explanation of a pheno hunt. Now, yes, he explained it in 2 minutes, and this, in essence, would take maybe, let's say, a 6-week veg, 8-week flowering time, like 14 weeks, then the cure, like 2 weeks, and let's go 3 weeks for the cure. Yeah, you're talking about like 17 weeks for this whole process. So I'm glad he explained it in 2 minutes. But out of that 17 weeks in total, that number 3 is everything that you wanted. So isn't that well worth it? Pheno hunting.
Go about hunting for good phenotypes. All of the popular phenotypes of gelato is another great example. Originally bred in Northern California, with genetics from the Cookie family and Mario Guzman, aka Sherbinski. It is a cross of Sunset Sherbet and Thin Mint Girl Scout cookies. Then they collected all the seeds from that cross and hunted for phenos. For simplicity's sake, let's say there were 100 seeds in this hunt, labeled 1 through 100. And it just so happened that numbers 33, 41, 43, and so on really stood out as being special. So special that they each got their own unique name. Gelato 33 became Larry Bird, and Gelato 41, my favorite pheno gelato, became Baccio Gelato.
Ah.
They had mother plants for each of these phenotypes, cloned them, and disseminated them throughout the industry.
Now, to go back to the previous, I guess, slide, he had the 5 seeds that he was breeding out. And these are all the different expressions of those 5, say. And we can see that represented through the gelato. That each of them are so unique, even though they all basically came from the same cross. Now, yes, a lot of that is due to, I guess, environment, phenotypical expression, where it was grown at. But also just the diversity in the genetics. You've got the pool of both parents to work with. And you can pull 5 distinctly different strains out of the same, basically, family. This is the importance of pheno hunting. And what you can get out of pheno hunting, more importantly.
But again, do not expect to see this level of quality in every batch of gelato you pick up at the dispensary. It all comes back to the environment they are grown in. Now, there are so many other qualities to look out for in a good phenotype than just color, aroma, and yield. And this slide just shows a few of those traits that growers and breeders look out for.
So we're going to go with, let's see. Oh shoot, I can enlarge this because I'm looking at this tiny screen on my OBS. So I'm sorry, it's a little delay. I gotta. Oh, I can't see this mother. I can't see it on there. But some other things he has here is vigor, plant structure. I know disease and mold resistance are huge. Leaf, like, how do the buds stack? How do the flowers stack? Are they pine coney and thick and dense? Are they wispy and sparse and, I guess, twiggy? Are the branches strong, durable? Do they have a lot of give? Are they fragile? Height, color, of course, taste, and I guess really it's going to come down to the high, the effect, and the taste. That's my three main things. Vigor does make a big difference. As I was saying with the dieselberry that I grew this summer, I decided not to clone it because of how what am I trying to say? How non-vigorous it was growing. It was very stunted, and it seemed easily affected by the cold. It was getting purple in July. So yes, the color I was looking for, it was beautiful, as I was saying, but I'm gonna need you to double yourself in size and put on some weight, chump. You need to do some push-ups. So there's always a reason to pop seeds, as I said earlier. And there's about 20 different factors he has up here for different considerations. Yes, it's always going to be the same genetic bank. You're basically going to be shuffling that same deck of cards. How they line up, how that deck gets shuffled and realigned is really going to matter what you keep. Hence the gelato reference from the frame earlier.
And with that, I'd like to pass the mic over to my good friend Jesse and have him take it away from here.
Oh, so that was
Great
Anders
info per
Peterson.
usual,
I
Bruce.
thought that was
Always great to
Jesse.
hear you talk about the science of phenotypic expression. And I think the gelato example you chose is a great one because it resonates with cultivators, brokers, and buyers alike. Think about sales for a second.
Okay, yeah, okay, so he's the business one. So we don't need to see the business part. But what we can do is get ready to get into our new segment, Strain of the Week. This is just where we're going to showcase a different strain. Doesn't have to be new, but just to kind of get the word out there. Just so you can hear different things to try out, if you so prefer. So without further ado, our strain of the week. Permanent marker.
Thanks for joining us today for our
And from my personal favorite, All Bud. Would you look at that? It's pretty. Yeah, nice pretty colors. The buds look pretty dense, thick. Looking nice. Looking nice. I get us a picture of it? Unplug it now. Permanent marker is an indica dominant hybrid. 70-30 indica dominant. 70-30 indica. I'm dumb. Permanent marker is an indica dominant hybrid strain. 70% indica, 30% sativa. Created through crossing the delicious biscotti, jealousy, and sorbet back cross strains. This three-way cross is a perfect daytime strain to help kick back and relax on a lazy afternoon without a care in the world. The high settles in after a few tokes, filling your mind with a sense of lifted creativity that is a happy feeling and artistically inspired. A slightly weighty sense of calm accompanies this blissful state, helping you to settle down and relax without causing too much sedation. A feeling of hunger finishes out the high. A feeling of hunger finishes out the high, leaving you totally ravenous and ready for snacking. Combined with a super high 34 to 35% average THC level, these effects make permanent marker a great choice for treating conditions such as chronic fatigue, PMS or cramps, depression or mood swings, chronic stress, or PTSD. This bud has a sweet and sour fruity citrus. This bud has a sweet and sour fruity candy flavor with a punch of citrusy diesel upon exhale. The aroma of a spicy diesel, pungent dank, and super sour citrus. Permanent marker buds have dense, oversized, spade-shaped, bright emerald green nugs with purple leaves, lots of thin orange hairs, and tiny amber-tinted white trichomes. Whoa. That sounded really good. I need to hear that again. Permanent marker buds have a dense, oversized, spade-shaped, bright emerald green nugs with purple leaves, lots of thin orange hairs, and tiny amber-tinted white crystal trichomes. The effects: aroused, calming, creative, happy, hungry, relaxing. They keep going with the hungry, don't they? It may relieve depression, fatigue, PTSD, stress, cramps. Flavors: candy, citrus, diesel, fruity, sour, sweet. Aromas: flowery, gas, pungent, sour. They said it was 34 to 35% average THC. Why am I not growing it? Man, oh man. Why am I not growing that? Well, thank you all. This has been another episode of the Cannabis Analysis. I appreciate everything. You enjoy yourself. And happy growings, fellow Cannabisians. You definitely enjoy yourself, because I know I did. Welcome to the Cannabis Analysis, the podcast that covers all things cannabis. We're going to talk, debate, examine, and get great. We are now live on YouTube, Rumble, and Kick. Don't forget to join our locals community. The link tree will be in the description box.